Okay, for this lesson, we're going to be talking about the fundamental theorem of calculus. So far we found areas looking at Riemann sums and trapezoidal rules, but the areas weren't exact. They were approximations. So now we're going to learn how to find the areas, getting the exact answer every time. So your integrals, you're going to see that there's these little numbers there now. This is called a direct integral. And this little a here, so this little number, is going to be the starting of our shaded region. So I'm going to label that the start. And then this little number at the top, this is called the ending number. So that's really where the shaded region ends. So I'm just going to draw a diagram over here. And let's say we have some curve. And we want to find the area between A and B. So the area would be that shaded region. Now the area is always the area between your curve and the x-axis. So it's either going to be above the x-axis, it could also be below the x-axis. Now that would be a negative area if that happens. So that's where the A and B come into play. It's the start and the ending point of the shaded region. So what you're going to do is we're still going to take the integral of our function here. And when we get our answer, we're going to then plug those numbers in. You're going to plug in the top number first, the B, and then minus, you're going to plug in the starting point, the bottom number, second. So I always remember it, it's top minus bottom. And again, that answer is going to be the exact area under the curve. So we won't have to estimate anymore now that we can do this integral where we know the boundaries. Okay, so we're going to start with some easy ones. We're going to start with the integral from 2 to 4 of 2x dx. So first I'm going to take the integral of 2x, which we take an integral, remember, by adding and dividing. So if I add 1 to the exponent and divide, I get x squared. And normally we put a plus c, but when we have an integral with boundaries, we don't need to put the plus c, because when we subtract the two numbers, we would be subtracting the c's and they would cancel each other out. So we're going to plug in the 2 and the 4. So we note that with a bracket on the end. That means that we're going to evaluate. So I'm going to write that in. That little bracket means evaluate. And we're going to evaluate from 2 to 4. Okay, so first thing we do is we plug the top number in first. So 4 squared minus, then we plug in the bottom number, 2 squared. So 16 minus 4 gives us 12. Okay, number 2. We're going to do the same thing. We're going to take the integral of x plus 2 first. So I'm going to add and divide. That's 1/2 x squared plus 2x, and I'm going to evaluate that from 2 to 4. Okay, next step, we're going to plug in the top number. So 1/2 4 squared plus 2 times 4 minus, then we're going to plug in the bottom number, 1/2 2 squared plus 2 times 2. Okay, so now I'm ready to evaluate. 4 squared is 16, divided by 2 is 8, plus 2 times 4 is 8, so that's 16. Minus, over here, 1/2 of 2 squared, that would be 4 divided by 2 is 2, plus 4, so that would give us 6. 16 minus 6 is 10. Okay, question number 3. First, I'm going to take the integral, so I'm going to add and divide. That's 1/3 x cubed plus 2x, and I'm going to evaluate from 1 to 2. Okay, next step, we're going to plug in the top minus the bottom. So I'm going to plug in the 2 first. Minus, now I'm going to plug in the 1. And now I'm going to evaluate. So right here, 1/3 times 2 cubed, that would give me 8/3, plus 6, plus 4, so that would be 20/3, minus, this would be 1/3 plus 2, so that would be 7/3. So overall, that would give me 13/3. Okay, next number 4. I'm going to rewrite. Anytime we have a radical in the problem, remember we want to rewrite that first. So that's 3x to the 1/2 dx. Okay, so next I'm going to take my integral. So I'm going to add and divide. If I add 1 to 1/2, that gives me 3/2. And I'm going to multiply the 3 in the front by the reciprocal, which is 2/3. So 3 times 2/3 is 2. And I'm going to evaluate this from 1 to 4. Okay, so I'm going to plug the 4 in first. 2 times 4 to the 3/2. Minus, now I'm going to plug the 1 in. 2 times 1 to the 3/2. And now I'm going to solve. So 4 to the 3/2 would be 8, right? The square root of 4 is 2. 2 cubed is 8. Times the 2 out in front gives me 16. Minus anything, 1 to anything is 1. So minus 2. That gives me 14. Okay, number 5 is next. I'm going to add and divide. So I get my integral is 1/3 x cubed minus 3x. And I'm going to evaluate that from 1 to 2. So I'm going to plug in the 2 first. 1/3, 2 cubed minus 3 times 2. Minus, now I'm going to plug the bottom in. So 1/3 times 1 cubed minus 3 times 1. Now I always put brackets around the second part so that I can remember I'm subtracting this whole quantity. And I also solve these as 2 separate pieces. So when I get my 2 numbers, I always remember to subtract them. So I'm going to find the first part over here on the left. That would be 8/3 minus 6. So that is negative 10/3. Minus, this would be 1/3 minus 3. So that would be negative 8/3. So that gives me negative 10/3 plus 8/3, which is negative 2/3. And it's okay to have a negative area. Remember, sometimes graphs are below the x-axis. Okay, number 6. Now, number 6, hopefully you remember, it's also on one of your note cards. We got to go backwards here. So if I want to take the integral of secant squared, I got to think to myself, what derivative gives me secant squared? So hopefully you thought to yourself, and hopefully you, if you didn't know, you looked it up on your note card, but it should be tangent, right? The derivative of tangent is secant squared. So if we're going backwards, the integral of secant squared would be tangent. And we're going to evaluate that from 0 to pi over 4. So same thing, we're going to plug in the top number first, tangent of pi over 4 minus the tangent of 0. So you have to know your unit circle, but you can look it up. If you need a unit circle, you can always go to embeddedmath.com. There's blank unit circles. There's a filled out one. That's the one that I've given you in class in pre-calc and at the beginning of this year. So if you need another one, you can go to that website. But the tangent of pi over 4. So pi over 4 is right here. And sine and cosine are both root 2 over 2, root 2 over 2. So tangent would be sine over cosine, so it would be 1. Minus the tangent of 0. 0, the coordinates are 1, 0, so sine over cosine would be 0. Overall, that gives us 1. Okay, last question. So we're going to number 7 next. And this time we have our own graph to set up. So you're going to have to use your graphing calculator for this one, so you might need to pause it and go get that. So it says find the area of the region bounded by the graph of y equals 2x squared minus 3x plus 2, the x-axis and the vertical lines x equals 0 and x equals 2. So first thing I'm going to do is graph that equation. So I'm going to go to my y equals, type in 2x squared minus 3x plus 2. And I'm zoomed in from my last time, so I'm going to zoom 6. I might not have to. It actually looks pretty good like that. So I'm going to leave it. I'm going to sketch a graph here. So I have my graph. We have an area that's bounded by this graph, the x-axis, so here's my x-axis, and the vertical lines, x equals 0 and x equals 2, which is somewhere over here. So I'm going to shade that region in. So what we want to do is find the area of this region, and I actually know my starting and my ending point. It's 0 and 2. So I'm going to set this up here. I'm going to set up an integral that goes from 0 to 2, and the area under the curve. So the curve is this equation right here, 2x squared minus 3x, plus 2. That's not anything there. I'm crossing that out. Okay, so we're going to do the same thing we did for the other questions. We're going to take the integral first. So I'm going to add and divide. So that would give me 2/3 x cubed minus 3/2 x squared plus 2x, and I'm going to evaluate from 0 to 2. Okay, so we're going to plug in the top number first. So 2/3 times 2 cubed minus 3/2 times 2 squared plus 2 times 2 minus, and then I'm going to plug 0 in. Now, fortunately for us, when we plug 0 in to all those x's, we get 0 back. So that saves us a lot of time there. So minus 0, I'm going to put that down already. So I just have to figure out this first number here. So you can use your calculator to type it in. So you might want to pause it and get that figured out and then check your answer here. But when you plug all that in, you get 16/3 minus 6 plus 4. So that's 10/3. 10/3 minus 0 is 10/3. Now, in the other lesson, I taught you guys how to check your work or get the actual area on your calculator. So I'm going to zoom 6 this so we can see this graph in full here. And we're going to find the actual area. We did this with the trapezoid questions. So I'm going to go to second trace. Number 7, you see the integral symbol there. And we're going to go from 0, enter, to enter. And I get 3.3 repeating, which is 10/3. Now I'm going to show you another trick as well. So let's go to the main screen of your calculator. You can also find definite integrals on your main screen. So you're going to go to the math button. I'll point to that right here, the math button. And you're going to scroll all the way down until you get to number 9. That stands for function integral. And it looks, if you have an 84, it's going to look fancy like this one. If you're using the Inspire, some of you have Inspires, you're going to go to Menu, Calculus, and then you'll see the integral there. You do it the same way then. If you have an 83, just hold up and I'll give you the directions for that. So you're going to type it in exactly how you see it. So you're going to put the little 0 in, the 2 up here. You're going to type your function in, 2x squared minus 3x plus 2, and then in the end, dx. And there we go, 3.3 repeating. Now, if you have the 83, you're going to type it in the same way. So you're going to go to Math, and then Integral, Function Integral, but it's not going to have the fancy integral come up. So if you have the TI-83, This is how you're going to do it. It's going to pop up with a function integral like this with parentheses. So you're going to type in the function 2x squared minus 3x plus 2, comma. You're going to put your boundaries in. So 0, comma, 2, and then at the end, the dx part, so the variable, comma, x. Now, the comma is right next to your parentheses. So if you can't find that, it's right there. Now, that's only if you have a TI-83. So if you don't, if you have an 84, you're all set. You shouldn't need that. But if you need help, if you're using a TI-83, just send me a message and I can walk you through that if you need more help with that. Okay, so feel free to go back and rewatch anything or email me with any questions.